see. Is this function? Yes, function.
Dr. Brice. Dr. Brice. Dr. Brice. Me. No, me.
Yes.
When is the test?
I don't know. Is it test? I don't know.
So it's not next week.
I'm guessing 2 weeks.
Yeah.
Something like that.
Okay.
I'm thinking pre-Thanksgiving.
Huh?
So you can enjoy pre-Thanksgiving. Before Thanksgiving.
Oh, okay.
All right, let's take a look at these guys. Hey, does this constitute a function? No. And notice this is a mapping, except they just left off the circles, right? Same thing as what I did. What's the problem child here? Yeah, got 2 lines of relationship from -1. That is not a function, so that's indicated it's not.
Whoa.
How about that guy? Is that a function?
Yes.
Yeah. Took you a moment to look, but every first element is just mapped to one thing in the range. Is a function. Hey, this is put in a different format, but do you see the ordered pairs? You see the ordered pairs?
It's
Like
not
0, -4 is an ordered pair. So realizing that, does this thing constitute a function?
No,
What's the problem?
because 1 and 0
1
repeat,
and 0 are both repeated as first elements, right? And that is the question I ask myself when I have ordered pairs. Is any first element repeated? Yeah. So which one of these? The last one.
Last one.
The input values of 0 and 1 are not matched, are each matched with 2 different ones. There we go. More ordered pairs, does that represent a function? Yes. Great. Overwhelming yes. Alright, check this out. Which sets of ordered pairs represent functions from A to B? How about first guy here? What's the problem? C's repeated. Did you notice that? You can't have that in function. How about this guy? Is that all right? How about this guy?
Yes.
Okay. How about this guy? Hey, I don't have any first element repeated. Why don't you say no?
Because the range is in the domain.
That's right. These are range elements right here. These come from B. These do not come from A. Notice the instructions. Function from A to B. This is a function from B to A, right? So middle 2 are functions from A to B. The last is a function, but it's not from A to B. Everybody see what we're doing? No big deal? All right, here's an evaluate problem. They give you a function. There it is right there. And they say, what's g of 0? What's g of 8/5? What's g of s plus 1? So it's your idea, everywhere there's a y, you're going to substitute 0, 8/5, or s plus 1. So what do we get on a g of 0? 8. What do we get? 8. 8, because 5y is 0, so 8 minus that is 8. Now what's 5 times 8/5? 8. 8. So 8 minus 8 would give me, that'll give me 0. Now remember, I'm going to put s plus 1 right there for the y, which means I have to multiply 5 times parentheses s plus 1. is it S plus 1?
Yeah.
So it's 8 what?
Minus 5s.
Minus 5s.
Plus 1.
Plus 5 or minus 5?
Minus 5.
Minus 5 times that, minus 5 times that. Combine those two.
3 minus.
So 3 minus 5s.
Can you also put negative 5s minus 3?
Yes. I don't know if they'd be happy with it, but that'd be fine. Okay, S of r equals 4 pi r squared. So whatever they give you, you're going to square, multiply by 4 pi. Right? So 4 pi times 7 squared. So 49 times 4, anybody got that? $49 times 4. 196. Everybody see where we get the 49, right? 7 squared. So it's 196 pi. Now watch this. You can actually go pi. Or you can go to the Greek section and expand it a little bit. And there's pi. Okay? Hey, I put 1/6 in there, I square 1/6. What's 1/6 squared? 1/36. 1/6 squared means 1/6 times 1/6, right? That's 1/36. So 4/36 reduces to 195. You might want to try any variety here. And you want to leave it 4/36 and see what happens? Let's see how picky it is. And 3r I have to square. It gives me 9r squared. 4 times pi times 9r squared. That's 36 pi r squared. Let's see if it'll go for 436. Didn't he make it simple? I think y'all can handle that one okay. All right. Number 9, find all real values of x such that f of x equals 0. What's another way of saying find where f of x equals 0? What are we finding? The zeros. You're finding the zeros of a function if you are finding where f of x equals 0. So I set f of x equals 0. 0 equals 7x plus 5. Right? Subtract the 5, x is going to be, can you tell? Negative 5 over 7. Everybody see that okay? All right. Let's pause for a second before we go to number 10. because it asks us for the domain of a particular function. I want to remind you of something that we've looked at before in a different context. We looked at this with a different title. The title was Limitations on the Domain of an Algebraic Expression. Okay, we got functions now, but notice the same two limitations apply. Exactly the same two limitations. Do you remember them? I cannot have any value of x that results in a 0 in a denominator. Remember that concept?
Mm-hmm.
Secondly, I can't have any value of x that results in a negative under a radical with an even index, like a square root and fourth root, something like that. So notice the first one in general applies to fractions. Did you notice that? The first one applies to fractions. The second one applies to radical expressions. So let's quickly go, I'll give you time to jot this down again. Let's quickly go back to this guy. This guy. And ask ourselves the question.